Next in this session, I have intentionally added arrays at this point in time instead of adding it along with the data types, because I wanted to touch upon the for loop first and then take the arrays. Okay. So array is nothing but it's a type of a data type wherein it's a collection of similar data types. Okay. So there is an integer, and if you want to define 10 integers of similar type, okay, say a roll number, then you don't have to define 20 different integer data types or variables, 20 different integer variables for 20 roll numbers. Okay. One roll number like this name, and this is the standard number, okay, like 20. So that makes 20 variables of integer type defined, okay, of same type. Like we explained before, this is an extension to the data type itself. Okay, array is not a new data type. Okay, there is nothing starts from array A. Okay, it's always int, float, character. It's an extension. A lot of integer variables collected together is called array. Can we select integer and float in one array? No. That concept is coming in a later stage when we discuss the structures. As of now, arrays is collection of similar data type. Array of integer, array of float, and array of characters. It's an extension of data type. Now we'll see how to use the arrays in the C program. What is the usage of it? We saw it's a collection of similar data type. Let me define on data type. Now how to make an array of it? Just use square brackets. So what it is trying to represent, or how it looks, is a of 0, a of 1, yeah. Likewise, it extends all the way till a of 9, okay, because we are talking about 10 elements, 0 to 9 are 10 elements, okay. And this is how we access these elements. And how do we initialize this? Like, we know how to initialize a single variable, but how to initialize an array? Use the flower brackets, okay. Use 0, 1, 2, 3, 4. Will remain others as it is. So this is also possible. Wherein in this case, the undefined or wherever the elements are not initialized, those will be initialized to 0. So now let me print it and show you. I would like to print a of 3. Yeah. A of 3 is 3. Yeah, it's here. Think about a of 6. It's 0. Okay. Now, since all these variables sit in memory, it has to occupy some of the time. Can we read a of 12? Speaking from the memory point of view, this is purely possible, and depends on compiler whether this compiler does compile it. Yeah, and it's reading some garbage value. Okay, because a of 12, I cannot set anything. Okay, but it can read something. If I actually need a of 12, then I have to, as a programmer, I'll be defining something which can accommodate 12 as an array. So now let's see the size of complete array. Okay, the size of complete array will be 40 bytes because each integer is 4 bytes. There are 10 such integers collected together. Okay, so if I see size of it is 40 bytes. Yeah. Each one you already know. On how to access one particular variable, we saw a of. Now I want to overwrite each and every variable. Okay. Or say I want to initialize, say I have 1000 here. So then I want to initialize everything with some value or different values. Then using flower brackets and writing will be a impossible task, close to impossible task, or that's not recommended to do it. I equal to 0, I less than 1000. Okay. So here I'll initialize this each variable to, let's use this variable a of 0. Okay. Or just for time being, I mean, just to show you non-zero value, initialize this with 12. And also I can print here. I'm giving a tabular, so that it prints, it gives a space after writing first element. Okay. Let's compile it and see. This is what it has printed. 12, everywhere 12. So there are 1012s are printed. Yeah. So this is a good use case of for and array. Let's demonstrate the usage of array. Here I'll be using the array, and I'll define the array, unsorted array, and I'll try to arrange the array in the ascending order. So just for example, I'll take 6 as an example. 9, 99, 5, 65. Then 2 more numbers. I'll take some random numbers, 3 and 35. Okay. So this is my unsorted array. So the output should look like it's sorted, like it's ascending order. So there is a logic in it. So we'll not go into logic. The main focus here is to understand how to use the array. Yeah. So I'll use the for loop first. Yep. I equal to 0, and this is a proper sorting and arranging algorithm. So it is 6 minus 5 minus 1 is the inner loop, and there is one more loop inside it, because the logic here what we are using is we'll compare each element with everything, and the moment it finds the one which is less than the other one, then it will get shifted. Yep. So I'll take a inner for loop now. J equal to 0, j less than 6 is the length of my array, and minus I, because at every iteration of j, one element will find its place correctly. At the end of every iteration of j, one element in the array will find its place. So what is the logic again? I mean, we are comparing. If this is greater than this, then do the swapping. Okay. So we'll add that comparison. If a of j, we have to use the inner loop here. If a of j is greater than a of j plus 1, then do the swapping. So to swap, I'll first take one element, I mean here, and the same element I'll assign the value of a of j. I mean, these are standard sorting, the swapping mechanisms. There are many ways to swap it. I mean, you can skip completely using the temp, but this is a straightforward way which I'm explaining. And now I have a sorted array, and I'll just print it now. I plus plus, and yeah, so I'll just print it one after the other with a tab. Yeah, so here we're making array meaningful use of an array where we have collected some data in array. Yeah, you can think of that scenario, and that array is not sorted. And using the same array, we can perform operations on each of the element of the array and still get the expected result. So here you can see this is sorted. Yeah, 3, 8, 9, 15, 20, and 55.